So now that we have all of this data from the ANOVA, we are going to be conducting a post hoc analysis, which basically is important because we're determining the significance between the groups. So between freshmen and sophomores, freshmen and juniors, and then sophomore and juniors. So we're going to come down here. And our initial alpha is 0.05. And in order to calculate the Bonferroni corrected alpha, we're going to need to divide it by the number of groups. So we have freshmen, sophomore, and juniors. So that means 3 groups. So we're going to do 0.05 divided by 3 equals 0.167. And we're going to be using an unpaired t-test. So we're going to do equals t-test. And we're going to be first comparing the freshmen to sophomores. So we're going to collect all the freshman data first. Sophomores. And then we're going to do two-tailed. Paired. And then we're going to do the same thing to freshmen and juniors. So we're going to do equals t-test. Select the freshman data. Then select the junior data. 2, 2. And that gives us our p-value between those groups. We're going to do that one more time between the sophomores and juniors. So it's going to be equals t-test. The sophomore data, comma, junior data, comma, 2, 2. And that gives us our p-values for all 3 of these. And now we have to determine whether it is less than our corrected alpha. So if you look at this value, 0.148 is definitely bigger. So that'd be greater than. So we say no. And then both of these are actually less than. Or this one is also no because it's greater than 0.167. And the one that is less than 0.167 is this one. Actually, I misread this one. This one's also yes. I misspoke. And now what we can conclude about the data based on these results is that there is a significant difference between freshmen and juniors, and there is a significant difference between sophomores and juniors, but there is no significant difference between the freshmen and sophomores just because their p-value is greater than our corrected post hoc alpha value.